we're going to look at drift velocity. So let's start off reminding ourselves about drift current. It depends on a few variables and it can be summarized as I equals nAvq. Let's look at the terms. The number density n is equal to big N over V. So small n is the number of charge carriers per unit volume, and big N is the total number of charge carriers in that volume V. So this gives us an idea about drift velocity, which is the net speed of charge carriers along the wire. If we start with I equals delta Q over delta T, rearranging it to delta Q equals I delta T, and we also know that delta Q, the total charge, is going to be equal to the total number of particles times the charge on each particle. So delta Q equals big N small q, which is equal to small n V small q. Also, since volume is equal to area times length, that means that delta Q equals NALQ. Now, if we bring in velocity as displacement over time, and here the displacement is the length, so L equals V delta T, that now gives us delta Q equals NAV delta T Q. Divide both sides by delta T and you get delta Q over delta T equals nAvq. So I equals nAvq, and I is known as the drift current, but we're learning this more for that value of V, which is called the drift velocity. Now, if you're going to prove something like this, you're going to have to start with the defining equations and write them out. I used I equals delta Q over delta T, V equals AL, and small v equals S over delta T. You should also include all the extra detail and words, since you're not just showing the steps, you're trying to convince someone.